Okay guys, so we are now officially done with Unit 8. We are moving on to Unit 9. Okay, today's lesson is going to be about inverse variation models. There's the do now. You guys should have done the do now by now in the Microsoft Forms. So let's go ahead and begin with today's lesson. So, inverse variation. There are going to be two types of inverses. One of them is going to be direct variation. Okay, and the other one is going to be inverse variation. Now, how are you going to know when you have direct variation versus inverse variation? Well, that depends on the equation or the formula that you get. So, for example, direct variation is going to be y equals to k times x versus inverse variation is going to be y equals to k divided by x. So, direct is going to be multiplication versus inverse is going to be division. Now, you may ask yourself, well, what is this k here in the middle? Well, we obviously know what y and x are, right? They're just x and y values. But the k, well, we don't know what that is, right? So the k in this situation is going to be the constant, okay? So k is the constant variation, okay? So k is just going to be a constant number, just like when you do like maybe the slope, y equals mx plus b. The slope is a constant. K is going to play a similar role to that right here, okay? So the best way for me to show you guys how this works is literally to go straight into an example. So I'm going to go ahead and say, I'm going to give you guys a table. Okay, so example number 1, we're going to have a table of x and y values. Okay, and the x value is going to be 2, 4, 10, and 15. Y values are going to be 15, 7.5, 3, and 2. Okay, and we want to know what relationship is shown below. Relationship is shown below. And this is going to be about variation, right? So what variation are we seeing here in this problem? Now, it's either going to be inverse or direct variation. Now, for me personally, I think there are two ways that you can work with this, right? So if you look at direct variation, okay, this is just going to be me on the side. Direct variation, okay? You have y equals to k times x. Well, if you look at the table that I gave you, the only things that we have are x and y. Okay, the one that is missing is going to be this k. Now we can also look at inverse variation, and you'll see that you have y equals to k divided by x. And once again, the only thing that we have are the x and the y. Whatever's missing is this k. So technically speaking, what we're going to try to do is we're going to try to solve for k in these equations. So if I do that, to get this k by itself, I would have to divide by x, right? So if I wanted to find k for direct variation, I would get y and divide it by x. For inverse variation, if I wanted to solve for k, I have division, right? So I would multiply by x. That way this cancels out, and what I do to one side, I do to the other. So if I wanted to find k, I would just multiply x times y, right? So we're going to have to play with x and y and see which one gives me a constant of k. Now notice that this is constant. That means that the k value cannot change. It has to stay the same every single time. So let's say if I were to try multiplication, I need to get the same k value every single time. So that means that here I would do 2 times 15. Well, what's 2 times 15? 30. So this right here is my constant of k. So that means that if I continue to multiply these two and over and over again, every single time that I do it, they should give me 30. If that works, then that means that this problem is going to represent inverse variation and not direct variation. So let's go ahead and continue. 4 times 7.5 is going to be 30. So then this one's working and this one's working. We can go ahead and move on. 10 times 3, that's 30. So that works. And then 15 times 2, 30. So that works. So then this right here is showing us that this is going to be an inverse variation, where K is going to be 30. I can also prove to you that it's not direct variation and that won't work, because we can go ahead and just do y divided by x. So we can go ahead and do this one for the first one, right? But we can do 15 divided by 2, okay? And that gives you 7.5. So that means that if I divide these, I should get 7.5 every single time. But notice here, I'm going to get 7.5 divided by 4, which does not give me 7.5, it gives me 1.8. So therefore, it is not direct variation because it just does not work out. Inverse variation does. Okay, so it is inverse variation where K equals to 30, or the equation is going to be y equals to 30 divided by x. Okay, so now let's move on to another type of question. Okay, so question number 2. Let's say, suppose x and y vary inversely, and x equals to 4 when y equals to 12. Okay? We want to write a model to represent this. The given information. Okay? So, you have a lot of key clues in this sentence. You just have to go back and see what stands out, right? So if I read this, we want to say, suppose x and y vary inversely. So if they're going to vary inversely and not directly, that means that we can go ahead and get x times y equals to k, or y equals to k divided by x. They also told you that x is going to be 4 and y is going to be 12. So if you have inversely, they gave you x and y, meaning that you should be able to find k in this situation, right? So they want us to write a model to represent the given information. Well, the model is going to be this right here. So we just need to use this equation to give us that, right? So x here is going to be 4. And y is going to be 12. Okay? Well, what are we missing? We are missing k. So I'm going to go ahead and do what we did in the previous one and just do x times y to give me k. Well, what's k? X, 4. What's y? 12. So what's 4 times 12? 48. So that means that k equals to 48, and the model is going to be y equals to 48 divided by x. And that right there would be my answer. Now, let's say I give you another question, right? Now, this question is going to be related to example number 2, okay? Now, my question is going to be, what is y when x equals to 10, okay? Well, guess what? We were given x, so that's good. Not only that, but we know what k is as well, right? And we have this equation right here, so all I have to do is get the x, plug it in for x, and what do we find? Y, okay? So, x is 10, k is 48. Now I want to know what is y. So I'm going to get y equals to 48 divided by 10. Okay, well, what is 48 divided by 10? 4.8. When do we get 4.8? When x is 10. Okay? Okay, so now let's move on to example number 3. Okay, and we're going to go ahead and we are going to insert this right here. So this is going to be our example number 3. Okay, so it's a word problem. So your math class has decided to pick up litter each weekend on a local park. Each week there is approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. Okay, and so now we have this table right here that is telling us the number of students is going to be N, and then the time in minutes is going to be T. Okay, so I would assume N and T that this is probably going to be X and this is going to be Y. Okay, so now the first question that we're going to have is what function models this data? Okay, well, it's either going to be one of two, right? So it's either going to be direct variation or inverse variation, or it's actually going to be neither, right? So it's going to be our job to figure out which one of these it is. Well, remember, for direct variation, it's x divided by y to give you k. For inverse variation, it's going to be x times y to give you k. And for neither, that just means that neither one of these two worked, right? So we have to go ahead and figure out which one of these two it's going to be. Now remember, they have to give you the same constant every single time. So let's go ahead and see if it's direct variation. So let's get x divided by, it's not x divided by y, it's y divided by x. So let's do the y, which is 85, divided by 3, okay? That right there is going to give you 28.3. Okay, let's do 51 divided by 5. Gives me 10.2. So are these the same k values? No, they are not. So therefore, it is not going to be direct variation. Now let's go ahead and check out inverse variation. Okay, I'm going to do a different colors just so that it pops out a little bit. Okay, inverse variation. Let's go ahead and see. That's going to be x times y, so that's going to be 3 times 85. Okay, that's 255. So now let's go ahead and do 5 times 51. And that is also 255. Now I'm going to go ahead and continue with 12 times 21. Oops. And that is going to give me 252. And now let's do the last one, which is 17 times 15, which is going to be 255. Okay, now all of them are 255 except this one right here. Okay, this one's a little bit off by 3 points. Okay, you cannot often describe real life data exactly with the function rule, but we can go ahead and say that 252 is pretty close. It's close enough to 255. So the inverse variation is still a good model for this. Just because it's off by a little bit, it can still work. Okay, guys? So just, be on the lookout for that. Just because you see it doesn't mean, it's completely wrong. This is a real life, real world explanation example. So if it's off by a small fraction, like a little bit like this, it's okay. So that means that here, what type of function models this data? Well, an inverse variation. Inverse variation is what models this data. Okay? Now, that means that if k is 255, then my model is going to be y equals to 255 divided by x. Okay, and that right there would be my answer for the first question. Okay, make sure that you guys memorize these formulas, or that you're going back and forth to check what the formulas are, because that's what I've been doing. Now, the second question is going to be question number 2. How many students should there be to complete the project in at most 30 minutes each week? So let's go ahead and see what information is provided for us in this question. So we know that we have students, right? And if I look at this right here, students is going to be X. So that means that I want to know, if they ask me how many students, that means that they're trying to find how many students that is. So that means that X right here is unknown, right? They're telling us here that they wanted to complete it in 30 minutes. Well, what's 30 minutes? That's Y. So that means that here, Y is going to be 30. Now, the only other thing that I need to know is K, but I already know it because we found it over here on this side. So what is K? 255. We know that Y equals to 255 divided by X. Or we can also use X times Y equals to K, right? Which means X times 30 equals to 255, right? So you have option 1 or you have option 2. Literally, whichever one you want to use, it's your call. That means that here we can, instead of Y, we could put 30. Okay, so you can either solve for X here or solve for X here. Personally, I think the second one is a lot better, because all you would have to do is divide by 30, and X is going to give you 255 divided by 30, which is 8.5. So how many students do they need is 8.5 students, which... Can you have 8.5 students? No. So we have to round this up to say that they are going to need 9 students. Okay. Now, can you use this equation right here to solve this problem? And is it going to give me the same answer? Yes. So literally you can choose whichever equation you want. It's up to you. It doesn't matter. At the end of the day, they're both going to give you the same answer. So inverse variation and direct variation are literally just going to be your way of being able to manipulate these equations. Okay. That's the end of today's lesson. And yeah.